Hello fantastic people, I hope you are doing great. Today I would like to talk a little bit about basics. There is something we use every single day, but I'm sure many of us still don't understand it fully. I'm talking about vector normalization. So the page you see over here is my personal website. You can get to it by going to ptit.net and then you can go to resources, and then there will be a growing number of resources which you can learn from. And the one that we'll have a look at today is the vector normalization. So we click on this one. In order to understand the vector normalization, we of course have to understand what a vector is. If you would like to know a little bit more about vectors, there's a tutorial explaining everything about them. You can find it somewhere here. But the basics should be enough for us. So basically, vector is a mathematical construct which consists of two elements. So it has a magnitude, which is a nice word for its length, and it has a direction, because obviously it points somewhere, so it's very easily represented by this type of arrow. So you see we have a length of the vector, and the arrow is pointing somewhere, indicating the direction of the vector. Over here, you see we have two colored dashed arrows, which are representing the vector's components. So this vector is in 2D space. So of course we can have three-dimensional vectors, four-dimensional vectors, and so on, so on. But I think the simplest way to look at them is in 2D because it is the most intuitive. So whenever we point the arrow somewhere, right, it is described also by the change in x-axis and in y-axis. And those are basically the components. So we have the x component and y component. Of course, having this, this is a little bit beyond the scope of this tutorial, but knowing all that about the vector, we can calculate the angle. So if you would like to learn about that, definitely let me know in the comment, and then I'll prepare a video about trigonometric functions, because that's what we need for that. But this is everything that we actually need to know about the vector. Why would we like to normalize vectors? What's the problem with vectors? So when we, for example, get input from the player, we usually do it by getting the y-axis and the x-axis. So if the character moves horizontally or vertically, there is no problem. As you see below the interactive part, there is the input that we have, right? So we have -1 or 1 in a specific axis. And this works as expected. However, if we use vertical and horizontal movement for the character, then you see the character moves a little bit faster than expected, right? So getting input from the player is like getting the x and y components of the vector, right? So as we've seen over here, let me do something like that. So you see our vector has a x component 4 and y component 4. Its total length is a little bit larger, so it's 5.66. You can calculate it using the Pythagoras law, but that's again a little bit beyond the scope of this tutorial. But basically, you see, what you have to know is that when you have x and y of the component with certain values, the vector that is created by those components will be almost always longer than n of those. I'm saying almost always because if you have a vertical vector, it will be equal to the magnitude will be equal to its y component, and if you have horizontal, the magnitude will be equal to its horizontal component. However, again, if we have a diagonal vector, anything else than perfectly horizontal or perfectly vertical, the length will be a little bit longer, and we can see it over here. So over here, I hope we understand now why. The character moves a little bit faster when going diagonally. It's because the vector that we assign here, or the vector that is created by getting the x and y components with magnitude 1, is a little bit longer than 1. So what we can do about this? We can normalize the vector. So what vector normalization is? In simple terms, we get a vector, any vector we want, and then we make it shorter so its magnitude is equal to 1. So we can grab any vector and then we basically make it shorter. This circle you see over here is called unit circle, and it's a circle with a radius of exactly 1. So basically what we do, we want a vector that kind of finishes at this circle. I see that the arrow goes a little bit beyond that. That's a little bit incorrect because it should be exactly at the circle, but I hope you get the idea. Now, how do we do it? In Unity, it's very simple. In order to get that normalized vector, we simply use the velocity.normalized. So this property normalized stores a normalized value for the vector. So from the mathematical point of view, it's pretty straightforward. Let me just draw a vector and normalize it. Now, at the very top, you see in this simple formula, we have our vector divided by its magnitude. That's how we mark the magnitude. So ultimately, it means that we grab the x component and y components and divide them individually by the magnitude of the vector. So in this case is 6.0, 5.0 divided by 781. And after everything, we have the 0.77, 6.64. And that's the normalized vector. This is important because it allows us to understand that this process is reversible. So basically, if we have a vector that's of magnitude 1, if we multiply it by any value, it will become longer and shorter. So for example, if we multiply something times 3, it will be 3 times longer and the magnitude of the vector will be 3. It is very useful for all types of forces, movement, and this type of stuff. So now let's have a look at some common use cases. The first one, the normalized vector is very often used as a direction. So over here we see the simple walking agent, which uses the vector of magnitude 1, and you see the speed is always the same. Doesn't matter if it moves horizontally, vertically, or diagonally. Then over here we have something pretty similar. So over here we have a simple agent that follows another agent, and they just move nicely, and you see that the blue dot is never going to reach ultimately it is going to reach because the orange agent is not really good at escaping, but basically I think you understand the idea. So the direction of the blue dot is changing, but its speed remains constant, and this is very important because this is achieved by using the normalized vector. And then ultimately the third example we have here is the knockback. So when a enemy touches the player, you see he's knocked back a certain distance or with certain force. And what's happening here is for the direction a vector is used, the normalized vector, and then it is multiplied by force. So if you're wondering what I'm talking about, over here on the left there are small snippets of code which you can look at, and this will probably make it a little bit clearer. So for each of those we have this nice whoops, the agent did something crazy. Probably it's not initialized correctly, but yeah, doesn't matter. You see ultimately it moves as expected, and you can see the snippet of code over here. This one has a snippet over here, and the knockback has a snippet over here. One important difference when it comes to Unity code, you probably notice that there are two ways of getting the normalized vector. First one is vector.normalized. This doesn't modify the existing vector, it just returns another vector that's normalized version or normalized length or of normalized magnitude. However, if we use the normalize method, that will modify the existing vector. So a vector that is much longer will become of magnitude 1 and will stay this way. So you have to be careful which one you use, because for your use cases different ones may be needed or expected. There is one more important thing to know about. So in mathematics you cannot normalize a vector of length 0. That's because this would result in a division by 0. So if you remember from the formula, in order to normalize a vector, we have to divide it by its magnitude. And in this case, the magnitude is 0, which is basically invalid operation. In Unity, this problem doesn't exist because what will happen, Unity will simply return the vector free 0, which is kind of a safe way of handling it. But this is not a normalized value of a vector 0. It's basically kind of a safe value, which makes it work and prevent different types of exceptions and problems. And that's all I have for you today. If you found this tutorial useful and would like to see more content like that, don't forget to subscribe to my channel and like this video. Have a fantastic day, love you, and bye bye.